Today we are going to discuss the Module 1, Chapter 2 topic, that is database system concept and architecture. In this module or in this chapter, we will be discussing about the internals of DBMS system software. What are the components uh, uh, components that makes up the DBMS software. So first let us discuss what is data model. Okay. Our fundamental characteristics of the database approach is that it provides some level of data abstraction. What do you mean by data abstraction? It generally refers to the suppression of details of data organization and storage, and it highlights of the essential features of the essential features of the data for an improved understanding of the data. Okay, so one of the main characteristics of the database approach is to support data abstraction so that different users can perceive data at their preferred level of details. Yes or no? So this characteristics we discussed in the previous chapter, that is data abstraction. Data abstraction means what? In simple words, if I want to say again, it is nothing but it is just hiding the storage details of the database from the end users and providing what is required for the end users. Okay, that means the manager, what data the manager is requiring, it will give only that data to the manager. If we take the banking database as an example, what data is required for the employee of the bank, only that will be shown to the employee of the bank. Okay, what data the user should know, or the customer should see, only that data will be shown to the customer, like this. Okay, so hiding the storage details, okay, and organization of the data, and only showing the essential requirement according to the perspective of user, that we call it as a data abstraction. How this data abstraction is achieved, okay, in the DBMS? Okay, it is using the concept called data model. Okay, what is data model? Data model, to define it, it is a collection of concepts that can be used to describe the structure of a database. Okay, I repeat once again. A data model is a collection of concepts that can be used to describe the structure of a database. That means it provides the necessary means to achieve the abstraction. Okay, necessary means to achieve the data abstraction. When I say structure of the database, what do you mean by structure of the database? It means the data types, relationship, and the constraint that we apply on the data. Okay, that is nothing but structure of the database. What is the structure of the database? Data types, relationship, and constant that apply to the data. Okay, so nowadays in the modern data models, okay, it includes some set of operations for specifying retrievals and updates on the database. Okay, especially in the object oriented databases and all, we can include, other than the data, we can include the basic operations for specifying retrievals and the updates of data in the database. One example I'll tell you. Now we can enter, okay, we can create a table for the entering the marks. Okay, course 1, course 2, subject 1, subject 2, subject 3, subject 4, subject 5, subject 6, like that. Subject wise we can enter the marks into the database. Okay, when I want to calculate the CGPA and SGPA, okay, I have to write one operation. Okay, I have to write a program. I have to write a logic. Okay, to add this, all this, and according to the some formula, I have to calculate the CGPA. That CGPA will be represented in the form of a operation. Okay, I'm entering the data, I'm entering the marks is my data. Okay, marks is my data. I can enter the marks, I can delete the marks from the database, I can update the marks. All that operation I will do in the DBMS. Okay, using the DBMS I'll do to the database. Now, if I want to calculate, okay, if I want to compute the grade or compute the CGPA, that time I have to write the some basic operation. Okay, so modern data model incorporates that basic operation also. Okay, basic operation also. So data model operation for specifying DB retrievals and updates. Okay, so we can perform insert, delete, modification, updation, all these things. So to define the some calculation of credit rating, okay, we have to go for user defined operations. Okay, user defined operations. Next, we will discuss the categories of data models. Okay, so there are three main categories of data models. Main categories. Many data models have been proposed. Okay, among that three, okay, which among that, okay, it has been categorized into three based on the types of concept that they use to describe the database structure. Okay, first one we called as a high level or conceptual data model. Okay, high level or conceptual data model. Okay, what this high level or conceptual data model? It provides concepts, okay, that are close to the way many user perceive data. Okay, perceive data. It always describe the concepts close to the way many user perceive the data. Okay, so conceptual data model uses the concepts such as entities, attributes, and relationship. I think now you are clear about what is entity, attributes, and relationship. Okay, so this conceptual data model, it defines the database in terms of concepts such as entities, attributes, and relationship. What is entity? It represents real world object or concept such as employee or the project, okay, from the mini word that describe the database. Attributes represent property of that particular entity which describes the entity like employee name, employee salary, date of birth, so on so. What is relationship? Relationship among two or more entities represent an association among the entities. Okay, like employee works for department, like this. So this is the conceptual data model. Okay, conceptual data model is represented using the entity relationship model. Okay, ER model. The conceptual data model is represented using the ER model that we saw in the previous chapter clearly. Okay, so conceptual model or high level model, what it will do? It will describe the concept that are close to the way many user perceive the data. Next we have physical or low level data model. What is this physical and low level data model? As we know, physical means it is always internal, okay, at the lower level of the database. At the lower level of the database, what you can see? Can you remember that database system environment I showed you? At the low level, you can see two cylinders, right? Yes or no? Two cylinders means what? How the data is stored. Yes or no? So, physical data model or high level data model describes the concept that or provides the concept that describe the details of how data is stored on the computer storage media. Okay, typically magnetic disk, okay, like that, hard disk, like that. Magnetic disk means hard disk. Okay, so concept provided by physical data model are generally meant for computer specialists, not for the end users. Okay, it is basically for the computer specialist or the programmers, not for the end users. Okay, in between these two extremes, that is conceptual data model and physical data model, there is a middle layer called implementation data model or representational data model, or another name is for logical data model. What is this representational data model or implementation data model or logical data model? It provides concepts, okay, that may be easily understood by end user, but okay, but that are not too far removed from the way data is organized in computer storage. That is like in between. Okay, it is not too low, too high. High means completely for the end user. Low means completely for the computer specialist. Implementation representation data model is like it is not too high, too low. Okay, it is like in the middle. Okay, in the middle. So neutral. It is neutral. So that means what? It have the concepts that may be easily understood by the end user, but not too far removed from the way the data is organized in the computer storage. Okay, so this is a representational data model. Okay, this include widely used relational data model. Okay, or our legacy data models like network data model and hierarchical data model, which I will be discussing very shortly in the coming sessions. Okay, so what is this representational data model means? By this time you know how to create the table. When we create the table, we specify that create table student, student name varchar 25, USN char 10, address varchar 50, then semester integer. Okay, like this. That means what? We are telling that we are storing the student data in this column. Okay, and we are also telling at the storage part also we are telling that we need a memory location of 25 characters. Okay, 25 character, that means this many bytes. Okay, one character is equal to 1 byte, so 25 characters means 25 bytes we need. Integer means according to our type of machine it can be 2 bytes. Okay, or 4 bytes. So 2 bytes per number we need. Okay, per digit we need. Like that we are specifying. So it is not so too internal or too external. So it is in middle level. Okay, that is implementation of representational data model. So this data model we much use in relational data model or relational database system. Okay, which is also called as record based data model. Okay, record based data model. Next, very important thing, schema. Okay, schema. In a data model, it is important to distinguish between the description of the database and the database itself. Okay, please be clear. Okay, in the data model, it is very important to differentiate between the description of the data base and the database itself. When I say database itself, what is that? Database itself is what? Which contains the values. Okay, actual values. So what is this description of the database? Okay, the description of the database is called as database schema. Okay, the description of the database, you are describing the structure of the database. Okay, you are describing the structure of the database, that we call it as a schema. Okay, when I take house, we are design the structure of the house. Okay, once the structure of the house is done, we should not change, or we will not change it oftenly. Yes or no? Okay, so that's what the description of the structure of the database we called as a database schema, and the changes should be infrequent. Infrequent means what? Once we define the schema, it should not be changed oftenly. Okay, it should not be changed very often. Okay, and this is also database schema is also called as intention. Okay, another name for database schema we call it as an intention. What actually database schema will be having? Database schema includes description of the database structure, data types, and the constraints. Okay, say for example college database. College database will be having entities like student, faculty, course, department. And faculty will be having faculty name, which is varchar, faculty ID, integer, okay, date of birth, date, okay, address, again character, type. Constraint. Constraint is that the faculty ID should not be more than 10 characters. Okay, faculty ID should not be more than 10 characters. That is the constraint or the condition I am applying on the data called faculty ID. Okay, so this all, whatever we describe all this, that we called as a database schema. The diagrammatic representation of the database schema we called as a schema diagram. Okay, schema diagram. So when we draw the schema diagram, data types will not be shown. Data types and relationship constraints will not be explicitly shown. We just show the entities and how they are connected or related to each other. Then next we have data schema construct. Okay, schema construct. In the schema or in the schema diagram, each components we called as a schema construct. As I told, college database. In a college database, we have student, faculty, department, course. This all together we draw it or describe it as a database schema. In that, we have individual component. Yes or no? In the college database, we have individual component. What are the individual component? A student. Okay, student is one component or object, and course is one component, and another department is one component. Faculty is one other component. So each one we called as a construct. Schema construct. Hope it is clear for you. Okay, schema construct. So here we discussed about database schema, schema diagram, schema construct. Okay, description of a database we called as a database schema. Okay, the diagrammatic representation of the database schema we called as a schema diagram. Okay, individual component in the schema we called as a schema construct. Example, course, student with respect to the college database schema. Now, let us discuss the difference between the schema and the instance. Okay, I told database schema is the description of the database. Okay, or describing the structure of the database we called as a schema. What is the another name for schema? We called as a intention. Okay, intention. So next we have a database state. Okay, so there will be a state, okay, for the database. The database will be in the initial stage, okay, initial state, okay, or it will be in the current state, or it is in a valid state or invalid state. Okay, so like the different state the database can be there. Okay, what is initial state? Initial state means what? When we start entering the data. Okay, when we start entering the data, fresh state of the first state of the database we called as the initial state. State means what? When we put the data into the database. I'll show you example. This is we called as schema diagram. Okay, this we called as a schema diagram, which is having the construct. This is one construct. Okay, this is another construct. Okay, this is another construct. This is one more construct. Okay, this is another construct, like this. This is schema diagram. We have only the entity name and the set of attribute. Okay, we are not put any constraints here, or the data type and all is not mentioned. This is just a schema diagram. Yeah, this we called as a database state. Okay, what is this database state? Database state is nothing but, you can see here. So course is the construct. Okay, course is a construct. It is having some set of values currently. Okay, so this we called as a database state. Schema means we will be having only the structure. Okay, schema is having only the structure. The structure with the values. Okay, structure with the values we called as a state, database state. Okay, structure with the values we called as a database state. Okay, so the actual data stored in the database at particular moment in time we called as a database state. Okay, hope you understood this. Also called database instance or occurrences or snapshot or extension. Different names are there for database state. Okay, so it is also called as database instance. Okay, instance, database instance, that is at particular moment in time. Okay, these are the set of data available in the database. Okay, database instance, snapshot, occurrence or extension. So clearly understand, database schema we called intention. The structure should not be changed frequently, whereas database state we called as extension. The structure of the database state can, the contents of the database state can change frequently. Why I am telling the state of the or the database state can change frequently? That why? Because the database contents is not stable. Okay. Today there are 20 students. Tomorrow another 10 students will join the department. I should enter that 10 students data into the database. That time today it was 20. Tomorrow it is going to be 20 plus 10 30. That means what? State is changing. And day after tomorrow two more students may leave. That time what I should do? I should delete that data. Yes or no? That time 30 minus 2, 28. The state will keep on changing. But structure, when I say structure, the student, student name, USN, semester, department, that will be same. Okay, the structure is same. The structure will not change. Okay, unless unless there is a big requirement change. Okay, requirement change. Otherwise, the structure of the database will be same. That's why schema is static in nature. Okay, database state, it keeps on changing. Okay, it keeps on changing as and when. Okay, as and when the data in the database gets changed. That's why we call it as extension here. Okay, so database state, the instantaneous content of a DB changes frequently. So it is having initial database state, the state when the database is loaded freshly or first time. Valid state, okay, the database in valid state. When we say the database in valid state, a state that satisfies the structure and constraint of the database. Okay, the state that satisfies the structure and the constraint of the database, then we call it as a valid state. If it is not satisfying any constraint, okay, unnecessary data and all it is having, then we call it as a database state is in invalid state. What is current state? Today there are 20 students data, that is current state. Tomorrow I will enter 10 more, then that will be the current state. Day after tomorrow 2 students data is removed, so that will be the current state. 28 students data will be the current state. Okay, initial state, valid state, invalid state, and current state. Okay, so this is the current state as of now. Okay, at next moment of time I may add one more new course. Okay, that time the state will change. That's why we say database state changes frequently. Okay, but the structure will be same. Yes or no? Can you see here? The structure will not change. The structure keeps same, but only the contents may change. Okay. Next, we have a very important concept called three schema architecture. Okay, three schema architecture. The goal of the three schema architecture, whatever I show in the next slide, diagram, yeah, this we call it as a three schema architecture. Okay, three schema architecture. So the goal of this three schema architecture is to separate the user application from the physical database. User application from the physical database. Okay. So in this architecture, schema can be defined at three levels. Okay. Schema can be defined at three levels. First one is internal level, which is having the internal schema. Conceptual level, which is having conceptual schema. External level, which is having external view or external schema or user views. Okay, three schemas we have. Let us see one by one. Okay, so here, what are the characteristics this three schema architecture will provide? Okay, before that, I just tell a three schema architecture is a quasi standard created by ANSI in the 1970s to support three of the important DBMS characteristics. We discussed DBMS characteristics in the chapter 1, right? Okay, we discussed four characteristics: self-describing nature, program data independence, multiple views, yes or no? Then the OLTP, correct? Okay. So here it supports three schema architecture, supports, okay, supports three characteristics: program data independence, multiple views, use of catalog to store the database description. So what is internal schema? It describes the physical storage structure and access path, how the data is stored, all this. Okay, what is the format of storage? Okay, what is the format, in what format the data is stored? Okay, full of storage details. At the lower level, only computer specialist will be knowing that. Okay, at the lower level, that we called as a internal level. Okay, which describe the physical storage structure, okay, physical storage structure of the database. The internal schema uses the physical data model. We discussed the data model, no, three different data model: physical data model, conceptual data model, implementational data model. So this internal schema uses physical data model, okay, and describes the complete details of data storage and access path or indexes for accessing the database. It is all about how the data is stored, in which memory location the data is stored, in what format data is stored, how which access path is used to retrieve the data, all about full of, okay, storage details. Okay, that's why it is having internal schema. Next we have conceptual schema. Conceptual schema or conceptual level describes the structure of the whole database for the community of users. Okay, when I say community of users, it can be banking users, it can be reservation user, it can be college users, like that. Okay, the conceptual schema hides the details of physical storage structure and concentrates on, okay, concentrates on describing entities like the entities, data types, relationship, user operation and constraints. Okay, here representational data model is used, or implementation data model is used. Now external schema, it describes the user views. So what we see, okay, how we visualize our banking account or online our banking account. Okay, that is external schema. Okay, how it is represented to the end users, okay, outside community, that we call it as a external schema or external device, okay, external level. So this uses the data model, conceptual data model. Okay.